Imagine holding a small sphere in your hand, like a marble or a ping pong ball. Now picture taking a special drill and making a neat hole right through the center, so that the leftover piece looks almost like a chunky donut, or as some people call it, a napkin ring. Here's the riddle that stumps even grown-ups who love math. If you drill this hole so that the napkin ring you're left with has a height of, say, 2 inches, how much volume does it have? Most people think the answer must depend on how big the marble or ball was to begin with. A ring left over from the Earth itself just has to be bigger than one from a ping pong ball, right? But this is where math surprises us. In the strange, wonderful world of geometry, the answer is, no, it doesn't matter. As long as the height of the ring, measured from the flat top to the flat bottom, is the same, the volume is always exactly the same, no matter the size of the original sphere. This curious puzzle is called the napkin ring problem. It feels like it shouldn't be true, but stay with me as we look closer. Picture first making a ring out of a marble. You drill through it so the leftover napkin ring stands 2 inches tall. Now for a wild experiment, let's imagine we could somehow bore a ring with the same 2-inch height straight through the entire Earth. What would you expect? Well, the drill would have to be so huge, it would leave just the world's thinnest, giant shell circling the middle of the planet. Yet, the ring's volume would still be, believe it or not, exactly the same as the tiny ring from your marble. How can this be? The secret is in the way the ring changes as the sphere gets bigger. A small napkin ring made from a marble is very thick and chunky in the middle. If you use a much bigger sphere, the ring is so wide that the edge spreads out for miles and miles, but the actual ring itself becomes thinner and thinner, almost like a ribbon. It turns out that the added width and the lost thickness perfectly balance out. So the math tells us for any sphere, if the leftover ring is always the same height, the volume never changes. Mathematicians even worked out an exact formula for this curious case. If h is the height of your napkin ring, the volume is V equals pi times h superscript 3/6. That means, say, for a ring 2 inches tall, no matter where it comes from, Earth, a baseball, or your friend's marble, the volume is the same. Geometry is filled with surprises like this. Problems like the napkin ring show us that math isn't just crunching numbers. It's sometimes about untangling real-life mysteries that seem impossible until you look a little closer. Next time you see a napkin ring at the dinner table, imagine what kind of amazing math hides inside.